All right, so we are going to go over our review right now. So, first thing is the know your vocabulary. So, I'm not going to go over every single vocabulary because a lot of that stuff I'm going to go over through the review anyway. But just make sure you know what all the vocabulary from the unit is. So, next we have our subatomic particles. As you should know, there are three of them. We have protons, neutrons, and electrons. Okay, the location in the atom, the protons and neutrons are both in the nucleus. The electrons are on the outside in the electron, we're just going to call that E minus cloud. Okay, symbol, this one really isn't a huge deal, but just so you guys know, it's P plus, N0, and E minus. Charge, easy one, protons are positive, neutrons are neutral, electrons are negative. Relative mass, this is a big one that a lot of people get confused on. Protons and neutrons have a mass of 1 AMU. Okay, just so you guys know, neutrons are slightly more massive than protons, but very negligible. So, not really, again, big deal that you know that, just an FYI. Electrons have a relative mass of 0. They are much, much, much smaller than protons and neutrons. So define isotope and give an example of two isotopes of the same element using shorthand notation. So an isotope is a different version of the same element. So for example, carbon has three different isotopes. There's carbon 12, carbon 13, carbon 14. Okay. The only difference between those three different carbons is the amount of neutrons. And since the amount of neutrons is different, the mass number will be different. So carbon, all carbons will have a atomic number of 6, no matter what. So I'm sorry. Yeah. So the bottom left number is always going to have a 6. Now, carbon 12 is going to have a mass number of 12. Carbon 13 will have a mass number of 13. And carbon 14 will have a mass number of 14. Makes sense, right? So this carbon, carbon 12, that has 6 neutrons. Carbon 13 has 7 neutrons. Carbon 14 has 8 neutrons. And that's the difference between the three. Okay. All right. So next up, we have our PNE charts. Now, when you're using a PNE chart, or when you're doing a PNE chart, you definitely have to have a periodic table open with you. Okay, so that's why I have that right next to this. So we're going to go kind of flip back and forth between that while we're doing that. All right, so when we have so this one we have protons, neutrons, and charge. Okay, since we have protons, that means we also have the atomic number. Atomic number is always the same as protons. Since we have protons and we have a charge of 0, that means we also have the same amount of electrons as protons. And since the charge is 0, that means it is an atom, not an ion. Okay. Now, for mass number, we just take protons plus neutrons. Okay. So we take 17. Whoops. We take 17 plus 18, and we get 35. Okay. Now, from here, we do the isotope notation. Top left number is the mass. Bottom left number is the atomic number. And now we have to identify the element. So to identify the element, we look at the atomic number, number 17. We find number 17 on the periodic table. That turns out to be chlorine. So we go back here and we just write down chlorine's symbol. All right, so next we have mass number, we have number of protons, we have number of electrons. Okay, so number of protons is the same as atomic number again, which means we have a charge of 0 because we have the same amount of electrons as protons, which means this is an atom, not an ion. We have our mass number of 40, and we have our atomic number of 20. So to get neutrons from there, we take mass number minus atomic number, and we get 20. Okay, that's a terrible 0. Sorry about that. 0. There we go. All right, so then we do our same thing over here. We do our mass number on top left. We do our atomic number bottom left. We look at the periodic table to identify it. That is calcium. So Ca. All right, so next we have sodium with a mass number of 23 and an atomic number of 11. So mass number 23, atomic number 11. Number of protons, same as atomic number, 11. Number of neutrons, 23 minus 11. We get 12. Number of electrons, there is no charge up here. So that means we have the same amount of electrons as protons. So 11, charge of 0, and it's still an atom. That is a quotes thing, not an 11. Sorry, I'll just write down atom. That is more simple. All right, so that's that one. Next, we have neutrons and electrons and a charge of 0. Now, since the charge is 0, that means our protons are same as electrons. Okay, and that also means it's an atom. Our atomic number is going to be the same as our protons, 46. And our mass number is going to be 46 plus 61. So we get 107. So 107 goes on top. 46 goes on bottom. We got to identify that. 46 is right here. So that's palladium, which is PD. So we put PD right there. All right, continuing down. Oh, there we go. So we have mass number, we have electrons, and we have charge. Okay, now since we do not have a neutral atom this time, first of all, it's going to be an ion since it's already not neutral. Then, since it's -1, that means we have more electrons than protons, one more electron than proton. So if we have 18 electrons, that means we have 17 protons. Okay, and that means our atomic number is 17. So now we want to find our neutrons. So we take 36, which is our mass number, minus 17, and we get 19. From here, we do our isotope notation. So 36 on top, 17 on bottom. Our charge is -1. And then we got to identify that. We don't even have to go to the periodic table for this one because we have it's 17. We already did 17 up here. So that means that this is Cl, because if it's atomic number 17, it will always be Cl. Now this is an isotope of this. They're both chlorines, but they have a different mass number. So that means they are isotopes of each other. This one is also an ion, and this one is also an atom. That's okay. That still works. All right, so next, we have nitrogen. Still need that mass number thing. All right, so our mass number is 14, because the top left. Our atomic number is 7. Protons are 7. Neutrons are 7. Electrons are 7 because there is no charge here. So charge is 0, and that is an atom. Okay. All right, that was a quick, easy one. Next one, mass number 17, number of protons is 8, and a charge of -2. So atomic number is 8. Is that next one neutrons? Yeah, next one's neutrons. So 17 minus 8 is 9. Electrons, now this is -2. So that means we have 2 more electrons than protons. So we have 10 electrons. Okay, this is an ion. And then we have to put in our charge, our mass number, and our atomic number. Then we identify atomic number 8 is oxygen. So we write oxygen in there. Okay. All right, next we have zinc. Okay, so our mass number, we don't know our mass number yet. Our atomic number, we can find zinc on here. Zinc is right there. It's atomic number 30. So we write 30 for protons, 30 for atomic number. Our charge is not 0. Our charge is +2 because we have 30 protons, we have 28 electrons. So that means since we have more protons than electrons, our charge is positive 2. Sorry, I should have had a question mark there from the on the review. My fault. That's what was That's what was throwing me off a little bit. Okay, so that is an ion. And now we can figure out our mass number. 30 plus 36, that is 66. And then we can complete our isotope notation up here. So 66 right there, 30 down there, and plus 2 right there. Okay? All right, so the rest of these I'm not actually going to write because that will, you don't need to sit here and watch me write. I can just kind of explain them. Okay, so what is the relationship between wavelength and frequency? All right, so wavelength is the length between two crests on a wave in the electromagnetic spectrum. Frequency is how many times a wave passes a certain point in a second. Okay, so when we have long wavelengths, that means we have small frequencies. So they are inversely related, not directly related. As one of them increases, the other one decreases. What is the relationship between frequency and energy? Okay, so as our frequency increases, energy also increases. Okay. And then next one, list the 7 types of electromagnetic radiation from lowest energy to highest energy. Okay, so I'm going to go slow. First one is radio waves. That has the longest wavelength, therefore lowest energy. Second is microwaves. Okay. Third is infrared. Fourth is visible light. Fifth is ultraviolet radiation. Sixth is X-rays. And seventh and highest energy is going to be gamma waves or gamma rays. Okay. Next, basically the same thing, but just for visible light. So this one from longest wavelength to shortest wavelength. So longest wavelength is going to be red. Shortest wavelength is going to be violet. And to remember this, you can just remember, and you probably heard of this at some point, Roy G. Biv. Okay, so red, orange, yellow, green, blue, indigo, violet. Okay, that's the order of the colors in the rainbow. And red is always going to be the longest wavelength with the lowest amount of energy. Violet will have the shortest wavelength with the highest amount of energy. Okay, oops, sorry. So next, describe the process of light being reflected by an atom. So that situation, we've talked about this in class several times. So what happens? Hopefully you can. Oops. So what happens is you have an electron. Okay, it's in its ground state or the lowest energy level it can be in. Okay, you have some energy that comes in. And I'm sure you can't see my hand from in the camera, but it comes in and the energy gets absorbed by that energy or by that electron. The electron then jumps up to a higher energy level. Okay, once it jumps up to a higher energy level, that is called its excited state. So it cannot hold on to that excited state indefinitely. Okay, eventually it's going to drop back down to its ground state. And when it does that, that energy that it absorbed gets emitted into the air. That energy that gets emitted is visible light. That's how you can see everything that you're seeing all the time, is that energy that gets emitted. Okay? Okay. That is everything. Good luck on your test.